It's approximately 2500 BCE. Your society has no written language, no metal tools, no wheels, no cranes or pulleys. Yet somehow, your people transport stones weighing up to 40 tons over 150 miles, shape them with extraordinary precision, and erect them in positions that align perfectly with celestial events. Positions that still work with perfect accuracy 4,500 years later. In this episode, we're exploring one of the most fascinating aspects of ancient monuments: the sophisticated geometric and astronomical knowledge encoded in megalithic structures. From Stonehenge in England to Newgrange in Ireland, from the alignments at Karnak in France to the stone circles of the Orkney Islands, ancient peoples created monuments that demonstrate advanced understanding of mathematics, geometry and astronomy, knowledge they achieved without writing, passed down orally through generations, and preserved permanently in stone. Modern technology, laser scanning, computer modeling, astronomical software, has revealed just how sophisticated these ancient builders were. The more we study these monuments, the more impressed we become. So settle in, because we're about to discover how Stone Age peoples without writing or mathematics as we know it encoded complex astronomical and geometric knowledge in monuments designed to last forever. Let's begin with the most famous megalithic monument in the world, Stonehenge. Built in stages between approximately 3000 and 1500 BCE, Stonehenge is far more than a simple circle of stones. Stonehenge consists of multiple concentric circles and geometric elements that work together as an integrated whole. The earliest element is an outer ditch and bank dating to around 3000 BCE. Within this outer boundary lie the Aubrey holes, a precise circle of 56 pits arranged with remarkable regularity. The monument's most iconic feature is the Sarsen Circle, comprising 30 upright stones crowned with lintels that once formed a complete ring. Inside this circle stand the inner trilithons, 5 massive stone gateways arranged in a horseshoe pattern. Additional elements include the bluestone circle and horseshoe, along with various marker stones and avenues that extend from the central monument. Each element is positioned with careful geometric relationships that demonstrate sophisticated planning and mathematical knowledge. The Sarsen Circle has an outer diameter of approximately 33 meters or 108 feet. The Aubrey Hole Circle measures about 86.6 meters or 284 feet in diameter. These aren't random numbers, they represent deliberate geometric proportions chosen by the monument's designers for reasons that continue to fascinate researchers today. Stonehenge's most famous alignment runs along the northeast-southwest axis. Looking northeast through the entrance, an observer at the center of the monument sees the midsummer sun rise directly over the heel stone. Looking southwest from the same central position, the midwinter sun sets precisely between the tallest trilithons, creating a dramatic spectacle that still draws thousands of visitors each year. But that's just the beginning. Researchers have identified numerous other astronomical alignments throughout the monument's complex structure, suggesting that Stonehenge functioned as a sophisticated astronomical calculator. The 4 station stones designated as stones 91, 92, 93 and 94 form a rectangle that encodes multiple astronomical alignments with remarkable elegance. The short sides of this rectangle point to summer and winter solstice sunrises and sunsets, while the long sides point to the most northerly and southerly moonrises, positions known as lunar standstills. What makes this particularly remarkable is that this rectangular arrangement only works at Stonehenge's specific latitude of 51 degrees. Move the monument north or south and the rectangle wouldn't have right angles, demonstrating that the builders understood the relationship between their geographic location and celestial observations. In the 1960s, astronomer Gerald Hawkins used a computer to analyze Stonehenge's alignments. He found that the monument could have been used to predict eclipses using the Aubrey holes as a counting system. Why 56 holes? Hawkins proposed that 3 times the lunar nodal cycle, 18.6 years, equals approximately 56 years. By moving markers around the 56 Aubrey holes, ancient astronomers could track and predict eclipse seasons. This theory remains debated. Some archaeologists think Hawkins overinterpreted the evidence, while others believe Stonehenge was indeed a sophisticated astronomical computer. Recent surveys using laser scanning have revealed remarkable geometric precision. Several alignments form Pythagorean triangles, right triangles with integer side ratios. For example, some researchers have identified 3-4-5 triangles and 5-12-13 triangles in Stonehenge's layout, the same ratios Egyptian architects used in the pyramids. Many archaeologists warn against reading too much into these numbers. With enough measurements in any complex structure, you can find ratios that approximate mathematical constants. The question is, did the builders intentionally encode these ratios, or are we seeing patterns that aren't really there? Beyond geometry and astronomy, Stonehenge demonstrates extraordinary engineering prowess. The sarsen stones, weighing up to 40 tons each, were quarried from the Marlborough Downs, approximately 20 miles away. The smaller bluestones, weighing up to 4 tons, were transported an astonishing 150 miles from the Preseli Hills in Wales. Each stone was then shaped and dressed with precision using only stone tools, creating smooth surfaces and curved lintels. The lintels themselves were secured using sophisticated mortise and tenon joints that held them in place atop the standing stones, forming a continuous, curved ring. Modern experimental archaeology has shown that moving and erecting these stones, while difficult, was achievable with Neolithic technology. But it required sophisticated planning, organization, and geometric knowledge to position them with astronomical precision. In the 1950s-60s, Scottish engineer Alexander Thom surveyed hundreds of stone circles across Britain and proposed a revolutionary idea. Ancient peoples used a standardized unit of measurement across vast distances and time periods. Thom, a professor of engineering at Oxford, spent decades meticulously surveying megalithic sites. He measured circles, alignments, and monuments with extraordinary precision. From his surveys, Thom claimed to identify a standard unit of 2.722 feet, or 0.829 meters, that appeared repeatedly in monument construction across Britain and beyond. He called this the megalithic yard, and proposed that it represented a standardized measurement system used by Neolithic builders. According to Thom's analysis, when you measure stone circles using megalithic yards, you consistently get integer or simple fractional values. Circles with diameters of exactly 10, 15, 20 or 25 megalithic yards appear too frequently to be coincidental. The spacing between stones often corresponds to whole or half megalithic yards, and monument layouts seem to follow grids based on this unit. This pattern, Thom argued, couldn't be explained by chance alone. In the 1950s-60s, Scottish engineer Alexander Thom surveyed hundreds of stone circles across Britain and proposed a revolutionary idea. Ancient peoples used a standardized unit of measurement across vast distances and time periods. Thom proposed that the megalithic yard was divided into 40 megalithic inches, about 0.8 out of 16 modern inches each, and that double the megalithic yard gave a megalithic fathom. Thom claimed to find evidence of this unit at sites across a vast geographic area. Scottish stone circles, including the Ring of Brodgar and Callanish, showed the pattern. English henges, like Avebury, incorporated megalithic yard proportions, and even elements of Stonehenge seemed to conform to the standard. Welsh monuments displayed similar measurements, and remarkably, the great stone alignments at Carnac in Brittany, France, appeared to use the same unit despite being hundreds of miles across the sea. The hypothesis suggests a shared measurement system across thousands of miles and potentially spanning centuries, implying either cultural contact or a common origin for megalithic traditions. Tom's work sparked intense debate that continues to this day, dividing the archaeological community. Supporters of the megalithic yard hypothesis argue that statistical analysis shows the unit appears too frequently across too many sites to be mere coincidence. The theory would elegantly explain the geometric precision observed in many monuments, and suggests a remarkably sophisticated mathematical culture existed in Neolithic Europe. They point out that similar standardized measures existed in other ancient cultures, such as the Egyptian royal cubit, making the concept entirely plausible. If the megalithic yard existed, it would indicate extensive cultural contact or shared origins among prehistoric European societies. Critics counter with several objections. They argue that with enough measurements from any complex structure, you'll inevitably find patterns that seem significant purely by chance. Different building phases at the same sites may have used different measurements, making apparent patterns misleading. Measurement errors accumulate over millennia as stones weather, shift, and deteriorate, creating uncertainty in the data. Most critically, no physical measuring rods, standards, or construction guidelines have ever been found in the archaeological record. Some claimed alignments and measurements don't hold up when subjected to modern, high-precision surveying techniques. Many of these shapes can be constructed using rope and stake geometry, techniques within Neolithic capabilities. The variations may have been intentional designs rather than construction errors. This indicates a level of mathematical sophistication far beyond what was once attributed to primitive Stone Age peoples. Let's turn to one of the most precisely aligned megalithic monuments in the world, Newgrange in Ireland's Boyne Valley. Built around 3200 BCE, older than Stonehenge, older than the Great Pyramid. Newgrange is a massive circular mound measuring 85 meters in diameter and rising 13 meters high. At its heart lies a 19-meter stone passage that leads to a cruciform inner chamber, topped with a remarkable corbelled roof that has kept the interior dry for over 5 millennia. The construction of this monument required moving approximately 200,000 tons of stone and earth. The exterior features a retaining wall faced with brilliant white quartz and darker granite, materials that had to be transported from significant distances. Around the base, 97 massive curbstones form a ring, many decorated with intricate carvings. Multiple stones throughout the monument bear megalithic art, featuring spirals, lozenges, and concentric circles, creating one of the most important collections of Neolithic art in the world. Above the entrance, a special opening called the roof box was deliberately designed into the structure. For 362 days of the year, the inner chamber is completely dark. But for about 17 minutes around sunrise on the winter solstice, December 21st, and only then sunlight enters through the roof box, travels down the 19-meter passage, and illuminates the inner chamber's back wall. How did Neolithic builders achieve this remarkable precision without modern instruments or mathematical formulas? Researchers believe the builders employed a multi-year process of observation and planning. They likely observed the winter solstice sunrise position over multiple years to establish its exact location on the horizon. Temporary wooden markers would have been used to establish and verify the alignment before permanent stone construction began. Using rope and stake geometry, they maintained accuracy during the lengthy construction process. As the structure took shape, they probably tested and adjusted the roof box position, ensuring the light would penetrate to the chamber's depths at precisely the right moment. Some argue this was achieved through trial and error. Others contend it required mathematical planning and geometric knowledge equivalent to that of Egyptian or Babylonian architects. The chamber roof stands as a marvel of Neolithic engineering, a corbelled dome where each stone layer projects slightly inward, from the layer below gradually converging until they meet at the apex some 6 meters above the chamber floor. Remarkably, this roof has remained completely watertight for 5,200 years, protecting the interior from Ireland's notorious rainfall. The builders achieved this through multiple clever techniques. They angled the stones to shed water away from the chamber, filled gaps and joints with clay and other waterproofing materials, and created a sophisticated drainage system that channeled water away from the structure. The fact that the chamber remains dry today testifies to the builders' understanding of hydrology and engineering principles. Newgrange's curbstones and passage stones display an extraordinary array of geometric patterns carved into their surfaces. The entrance stone features the famous triple spiral motif that has become an iconic symbol of Neolithic Ireland. Throughout the monument, you'll find concentric circles nested within each other, lozenges and zigzag patterns creating dynamic visual rhythms, and chevrons and wave patterns that seem to flow across the stone surfaces. Some researchers have proposed that these patterns encode astronomical information in symbolic form. They suggest spirals might represent the sun's cyclical movements through the year, concentric circles could serve as calendrical markers, tracking seasonal cycles, and the geometric patterns overall might function as mnemonic devices, helping preserve astronomical knowledge across generations in a pre-literate society. Others caution that we're projecting meaning onto abstract art, and the patterns may have had spiritual or aesthetic rather than astronomical significance. Newgrange is part of a complex including Noath and Dowth passage tombs, plus numerous smaller monuments, all demonstrating astronomical awareness. Noath has passages aligned to equinox sunrises and sunsets, showing that different astronomical events were being tracked and monumentalized across the same sacred landscape. Now let's explore the geometric principles that appear in megalithic monuments, patterns that later became known as sacred geometry. The golden ratio, approximately 1.618, appears throughout nature and was used extensively in classical architecture. But did Neolithic builders know about it? Egyptians used 3 to 4 to 5 triangles for construction centuries before the Greek mathematician Pythagoras. Evidence suggests knowledge of these triangles was widespread in the ancient world. These triangles are easily constructed using ropes with knots at specific intervals, practical knowledge that doesn't require understanding the mathematical theorem. The Fibonacci sequence appears in nature and architecture. Adjacent Fibonacci numbers approximate the golden ratio as the sequence progresses. However, with small integers being common in any construction, finding Fibonacci numbers may not be significant. The moon's movements are more complex than the sun's, and tracking lunar cycles demonstrated sophisticated astronomical knowledge. Unlike the sun, which varies between summer and winter solstice extremes annually, the moon's rise and set positions vary over an 18.6-year cycle. At major standstill, every 18.6 years, the moon rises and sets at its most extreme positions. At minor standstill, 9.3 years later, it rises and sets at its least extreme positions. Callanish in Scotland has stones aligned to major standstill moonrise and moonset positions. Every 18.6 years, the moon appears to skim the horizon through a specific stone arrangement. At Stonehenge, the station stone rectangle's long sides point to major standstill moonrise positions, an alignment that only works at Stonehenge's specific latitude. One individual couldn't observe the pattern alone. It required multi-generational knowledge accumulation and transmission. Similar geometric and astronomical principles appear in megalithic structures worldwide, suggesting these are fundamental approaches to encoding knowledge in stone. The Karnak stones comprise over 3,000 standing stones arranged in multiple alignments, rows, stretching for kilometers, dating to 4500–3300 BCE. This massive stone circle in Scotland's Orkney Islands, c. 2500–2000 BCE, demonstrates precise geometric planning. Dating to approximately 9600 BCE, Göbekli Tepe is the world's oldest known megalithic monument, predating Stonehenge by 6,000 years. Göbekli Tepe revolutionized our understanding. Geometric and astronomical knowledge existed much earlier than previously believed, even before agriculture. While not technically a megalithic structure in the traditional sense, the Great Pyramid of Giza, built around 2560 BCE, demonstrates geometric sophistication that deserves mention in any discussion of ancient mathematical knowledge encoded in stone. The Great Pyramid embodies multiple mathematical relationships that continue to intrigue researchers. The relationship between twice pi times the pyramid's height approximately equals the base perimeter, encoding the fundamental constant pi into the structure's proportions. The golden ratio appears in the slope and various internal proportions. The monument achieves precise cardinal orientation, aligned to true north within just 3.4 arc-minutes of error. Internal passages incorporate Pythagorean triangles in their angles and proportions, demonstrating sophisticated geometric knowledge. The pyramid's astronomical features are equally impressive. Internal shafts align precisely with specific stars, including Orion, Sirius, and circumpolar stars that never set below the horizon. The base achieves its cardinal alignment through careful stellar observations of circumpolar stars rotating around the celestial pole. Some researchers argue the structure may even incorporate knowledge of the precession of the equinoxes, though this remains hotly debated. Aboriginal Australians created stone arrangements with astronomical alignments. Wurdi Yuang in Victoria shows possible solar alignments marking solstices and equinoxes, potentially dating back thousands of years. When we step back and examine megalithic monuments across continents and cultures, striking patterns emerge. We consistently find circular and elliptical structures as the primary architectural forms. Solar alignments, particularly to solstice sunrise and sunset positions, appear almost universally. Lunar observations and tracking systems developed independently in multiple locations. Geometric principles guide the layout and proportioning of monuments from Britain to Australia. Most remarkably, these diverse cultures all chose to encode their astronomical knowledge in permanent stone monuments designed to outlast their builders by millennia. Most scholars favor independent development. Humans everywhere observe the same sky and develop similar solutions to tracking celestial cycles. But some evidence suggests prehistoric trade and contact was more extensive than once thought. So what have we learned about how ancient builders encoded astronomical knowledge in stone? The ancient builders achieved precise astronomical alignments that function perfectly thousands of years later, demonstrating knowledge that has been validated by modern astronomical software. They created complex geometric designs incorporating mathematical ratios that we're still analyzing today. Multi-generational observation programs tracked celestial cycles spanning decades or even centuries, requiring oral traditions strong enough to preserve technical knowledge across lifetimes. Possible standardized measurement systems emerged across vast distances, suggesting either extensive communication networks or common cultural origins. Most impressively, they developed engineering solutions to move and position massive stones with precision, using only Stone Age technology, muscle power, and brilliant problem-solving. Second, we've seen that these monuments weren't just religious or ceremonial. They were functional astronomical observatories and possibly computational devices. Stonehenge could predict eclipses, Newgrange captured the winter solstice with precision, stone circles tracked lunar standstills over 18.6-year cycles. Third, we've explored how geometric principles, whether intentionally sophisticated or practically derived, appear throughout megalithic construction. Pythagorean triangles built before Pythagoras, circular geometry requiring understanding of pi, possible golden ratio relationships and complex shapes constructed using rope geometry. Fourth, we've examined the ongoing debate about the megalithic yard and standardization. Whether or not a precise standard existed, clearly some shared knowledge and techniques spread across Neolithic Europe. Fifth, we've considered the remarkable achievement of knowledge transmission. Without writing, astronomical knowledge spanning decades, even centuries, was preserved and passed down through oral tradition, practical instruction, and permanent stone monuments that served as three-dimensional textbooks. Sixth, modern technology has revealed more than the builders could have known they were achieving. Laser scanning, computer modeling, and astronomical software show precision that astonishes us even today. But we've also seen the need for caution. Not every number is significant. Not every alignment is intentional. We must be careful not to project modern mathematical concepts onto ancient peoples or see patterns that aren't really there. What we can confidently say based on solid archaeological and astronomical evidence is substantial. Ancient builders possessed sophisticated astronomical knowledge that allowed them to track and predict celestial events with remarkable accuracy. They understood geometric principles, whether through formal mathematical systems or intuitive practical application accumulated over generations. With simple tools, ropes, stakes, plumb bobs, and careful observation, they achieved precision that impresses modern engineers. They invested enormous communal resources in encoding this knowledge permanently in stone monuments built to last millennia. Most remarkably, their monuments continue to teach us today about their capabilities, priorities, and understanding of the cosmos, speaking to us across thousands of years in the universal language of geometry and astronomical alignment. The megaliths speak to us in the universal language of geometry and the timeless patterns of celestial movements. They tell us that our ancestors, even 10,000 years ago at Göbekli Tepe, were observing the sky, recognizing patterns, developing mathematical thinking, and creating monuments to preserve their hard-won knowledge for future generations. When we stand before these ancient stones, we're not just looking at impressive engineering. We're standing before textbooks written in stone, astronomical observatories built to outlast civilizations, and testaments to the human drive to understand our place in the cosmos. If you enjoyed this exploration of sacred geometry in megalithic monuments, please hit that like button and subscribe. We have upcoming videos on ancient astronomy, lost mathematical knowledge, and the engineering marvels of ancient civilizations. Your support helps us create these thoroughly researched videos. Which megalithic monument fascinates you most? Do you think ancient peoples encoded advanced mathematical knowledge we're still discovering? And what other ancient mysteries should we explore? Thanks for watching. And remember, the next time you see an ancient stone circle or megalithic monument, You're not just looking at old rocks. You're standing before a sophisticated astronomical instrument, a geometric masterpiece, and a message from people who lived thousands of years ago, written in the eternal language of mathematics and stars.